Yo, what's up my amoebros? Welcome back to the highly recognized intellectual web show Biocraft, where we discuss highly important mechanisms that occur in cells. On this episode, we'll explore the process of osmosis. I'm Anastasia, and I'm accompanied by three other amoebros, John, Shawn, and Maddie.
I will be covering the process of osmosis.
I'll go over how the cell membrane works.
And I will end off with the movement of particles during osmosis.
Osmosis is kind of just a way that water passes in and out of the cell membrane while keeping other things, like salt, on one side of the membrane. It acts like a scanner or the guard of the cell. Osmosis is also passive, meaning it doesn't need energy. Our model here of this is these piglins guarding a bastion. The bastion will be the cell with the piglins as the cell membrane. Now, as you can see, if someone tries to enter the bastion without gold representing water molecules, they get attacked and aren't allowed in. On the other hand, if someone who has gold armor tries to enter, they're permitted access.
Currently, we use the Singer-Nicholson model of the cell membrane, which consists of a discontinuous bilayer of phospholipids, which our Minecraft model is the red concrete with the pink concrete tails. There are also peripheral and integral proteins in the cell membrane. The peripheral proteins stay on the surface of the cell membrane, which is the small orange concrete blocks right here, and the integral proteins go all the way through. It's the purple concrete. We've also got a little bit of cholesterol in there as well, represented by this nice yellow concrete. Along with that, some lovely little glycoproteins that sit on the exterior are represented with light blue concrete. But here's the fish, ooh. Since the lipid tails are hydrophobic, how does the water get through? Water, what are we gonna do? That's where the integral proteins come through. And what do these do? Aquaporins, or integral proteins, transport the water in and out of the cell. This can be represented with a nether portal letting the player in and out of the nether dimension in Minecraft.
Thank you, Maddie. So this segment will consist of explaining the movement of water particles in osmosis. The movement of the particles in osmosis is very similar to diffusion, another mode of transport that we covered last episode. Like diffusion, a greater concentration of water molecules will move to an area that has a lower concentration of water molecules. As you can see in our model with these blue sheep, which represent the water molecules, there are times in which the distribution of water molecules are unequal. In order to prevent creating a hypotonic environment in which the water concentration greatly outweighs the solute, the movement of the particles in osmosis is always constant. If the process of osmosis were to stop functioning correctly, the cell bursts due to the large accumulation of water inside it, which is part of another process called cytolysis.
That was a very riveting presentation there, guys. Really seemed to fit a boatload of information into one video. Topics really seem to flow into each other well.
You're very welcome, Anastasia.
I hope that you all are fishful that we stopped these puns and are expecting more next time. That concludes this episode of Biocraft. See y'all in the next episode.